Now that we've looked at how to name our normal distribution and how the mean and standard deviation impact exactly how our curve is going to look, I want to introduce you to something called the empirical rule. So this rule is going to make use of two of the properties we looked at earlier with those density curves or probability distributions. So the first property is that that height of the distribution is the probability for that value. So all of those are probabilities that are underneath that curve. And then the entire area under the curve is equal to 1 square unit, or that's 100% of our probabilities. So let's take a look at this normal curve that's here on the slide. We have our normal unimodal bell-shaped symmetric curve, and then at the center is mu. So remember, our mean is at the highest point, that peak in the center of the curve. And then they add 1 standard deviation, then 2 standard deviations above, and then 3 standard deviations above. And then they subtract 1 standard deviation, then 2 standard deviations below, and 3 standard deviations below. So the first part of this empirical rule is that within 1 standard deviation, so that's -1 and +1 standard deviation, 68% of the data is within that 1 standard deviation. So that means if I chose an individual from our population at random, there's a 68% probability that their value is going to be within 1 standard deviation of the mean. Okay, so the second part of this rule, approximately 95% of the data is within 2 standard deviations of the mean. So that would be adding 2 standard deviations and subtracting 2 standard deviations, and that's going to be 95% of our data, which is a lot. It's almost all of it. Within 3 standard deviations, that's 99.7% of our data. So that's 0.3% that's left over outside of those 3 standard deviations. So the vast majority of our data is going to sit within 3 standard deviations of the mean. So I want you to go ahead and get out this worksheet. This is a separate printout from the notes, and I'm going to go through and help you break these probabilities down so they're a little easier to use. All right, so here is this worksheet, and the first thing I want to look at is the mean and the median. So if you remember back to chapter 2, the median splits your data into 2 equal parts. So it's 50% and 50%. So our mean and median both sit here. So that means that 50% of our data is above that, and 50% is below. So that one's not too bad. The next part of that rule said that 68% of our data is within 1 standard deviation. So that would be from here to here. And so that'll be 68%. And then remember that this is symmetric, so that means these two pieces here are going to have the same area to them. So if I take that 68% and split it in half, I get 34% and 34%. So each of those are worth 34%. And then what's left over here, if this is 50 from here down, and this is 34, I can take that 50% here and subtract off the 34%. So that tells me that there's 16% left over here. So there's 16% that's more than 1 standard deviation below the mean, and another 16% that's more than 1 standard deviation above the mean. Okay, since we found these two pieces here, what I'm going to do is I'm going to come down to the bottom of the page. There's a little bigger curve here, and I'm going to fill those two probabilities in since I know exactly what each of those slices are. So those are each 34%. All right, so the next one, within 2 standard deviations of the mean, so that's 1, 2, so that's here, and then 2 below, so that's here. So we know that this is 95%. And then that leaves me with a 2.5% on each side. So there's a total of 5% left over, and then I have to split it between those two sides. So each side here is worth 2.5%. And then we know that this is 34, and this one's 34, and now we can use that to find this piece here. So there's a couple different ways we could do that. So I know that this is 50%, and I could take 50% and I could subtract 34, and then subtract 2.5. I could take, let's see, this 50%, this 16% that's left here. So we know from up here that that's 16%, and I could subtract off that 2.5%. So there's a couple different ways always to get these probabilities. You can kind of play around with that, but ultimately this is going to come out to be 13.5%. So we took 16 and subtract off 2.5. We'll get 13.5% there. And so now I'm going to transfer those two down to the bigger one at the bottom. So each of those is 13.5%. Okay, and then within 3 standard deviations, so that's almost all of this, all the way out here, this is 99.7% of our data. So if it's 99.7%, that means what's left over, so my total leftover is 0.3%. And then I have to split that between these two tails. So that gives me 0.15% and 0.15%. And so that's for everything out past the 3 standard deviations. So I'm going to put a 0.15 on each of these. And then I have one number left still to find here. And that's this one from 2 to 3 standard deviations. So what I'm going to use is I'm going to use this part that said from 2 standard deviations out is 2.5. And then I'm going to subtract off the 3 standard deviations, so the 0.15. So if I take 2.5 and subtract 0.15, what I'm left with is 2.35% on each of these. All right, so come back in the next video and we'll take a look at how to actually apply this and use it.